All right, so here we have a data file open. This is our SAT data file for schools in Pennsylvania. We're going to use this data file to demonstrate how we conduct difference of means tests in SPSS. So you can see here that the unit of analysis for this data file are schools in Pennsylvania. Here we have all schools. So we have middle schools and high schools and elementary schools, as well as charter schools and cyber schools. And we have, at the end of the data file, information about SAT scores. So we have the number of students tested, we have a reading average, a math average, a writing average, and then a composite score based off of those three sort of scores. We have a variable denoting the region of the state that each school is in. We have a dummy variable for SAT. Since some of those are middle schools, they obviously don't offer the SAT, so those are coded as 0. High schools that do offer the SATs are coded as 1. And finally, a dummy variable for whether or not the school is a charter school. So here I'm going to want to compute a new variable that just takes into account the reading score and the math score. That'll give me the traditional kind of 1600-point SAT score. We're looking at just the reading average and math average combined. So to do that, I'm going to go to transform, compute variable. I'm going to create a new variable called SAT2 that is going to be equal to the reading average score plus the math average score. And you can see now that we have a combined average score for SAT2, which is out of the typical 1600 by only taking into account those two elements, the reading average and the math average. So the first thing we might want to do is we might want to simply know what the mean SAT2 score is in Pennsylvania. So to do that, I'm going to go back to Analyze, Descriptive Statistics, and Descriptives, and then use that SAT2 score as my variable. So you can see here that when I do it, that the minimum score for SAT combined, once again, reading and math, is 646. The maximum score, average score for that first school is 1333. Once again, you can see here then that the mean is 966. So the average of all school districts' SAT scores, taking into account, once again, the reading and math average, is a 966 with a standard deviation of 108.9. So while it's really useful, we'd want to see perhaps how that Pennsylvania average compares to the national average. So to do that, we can use a one-sample difference of means test. So once again, keep in mind here that we are looking at a 966 and basically a 109 for our standard deviation. So 966 and 109. So to do that, we're going to go to Analyze. We're going to go to Compare Means, and we're going to do a one-sample t-test. Once again, it's called a one-sample t-test because we only have one sample. We have SAT scores for the state of Pennsylvania is our sample, and we've got it for 1 year. So we're going to compare this one sample, our Pennsylvania scores, let's say, to a national average. So we're going to go one sample t-test, and here it asks me for my test variable. So I'm going to use my SAT 2 scores, my test variable. And the test value here, this is what we know the mean to be. This information would be the population parameter that we talked about in an earlier video in this series. So if you go and look up national SAT scores, the average national SAT score for all students across the country is 1,059. So remember, we have a 966 average SAT score in Pennsylvania with a standard deviation of 109. We're going to test our sample values of 966 and 109 against the national average of 1059. Once again, our question really being, is our 966 for Pennsylvania statistically different from the 1059 average score for the rest of the country? So we click OK, and here we get a t-test. So you can see here that we get our sample statistics again that we had above. We have our mean of 966 and our standard deviation of 109. All the important information for doing our difference of means test is down in this bottom box here. So recall that our null hypothesis is that our sample mean in this case 966.36, is the same as our sort of population mean of 1059. Or in other words, the null hypothesis is that Pennsylvania as a state really is no different from the rest of the country when it comes to SAT performance. Our alternative hypothesis is that Pennsylvania is different from the rest of the country when it comes to SAT performance. So what we want to do is we want to conduct a t-test of statistical significance. And if you look at the formula for a one sample difference of means t-test, it is in the numerator, the sample mean minus the population mean, so x bar minus mu. And the denominator, we have the standard error of the mean. So to calculate that, if we were to do this by hand, we would take our sample mean of 966.36, subtract 1059, that would be our numerator, and that would give us a difference of negative 92.64. So if we were doing this by hand, once again, the numerator would be negative 92.64, which is simply the mean of our sample subtracting our test value of 1059. To calculate the denominator, if we're doing this by hand, we're trying to calculate the standard error of the mean. SPSS gives you the denominator in the first box, which is 4.28, and we would get that by hand by dividing our standard deviation of 108.87 by n, in this case 646, really the square root of n, so the square root of 646. So just to illustrate here, if we take the square root of 646, we get 25.41, 25.42. We can divide our standard deviation by 25.42, and that gives us our standard error of the mean. Here you can see that it's correct out to 2 decimal places, a little bit of error from the rounding that I did when I put it into the calculator. But once again, we can do this all by hand. There's no reason to, because SPSS calculates the standard error of the mean from the standard deviation and n, and then it calculates the mean difference by using our sample mean and the value we plugged in for the test value. If we do that calculation where we divide the mean difference by the standard error of the mean, that is, we divide negative 92.64 by 4.29 or 28, we would get a t-score of negative 21.626. Once again, we can show here that if we divide our 92.64 by our standard error of the mean of 4.28, we essentially get that t-score of negative 21.6. So the t-score then is what we need to evaluate whether or not our sample mean is statistically significantly different from our population mean. Fortunately, when we use SPSS, we do not have to go to a t-distribution table, and SPSS reports the significance level here for you in this bottom table. So here we see significance level for a two-tailed test. Once again, keep in mind the two-tailed is more conservative than a one-tailed test. So here we have significance to a two-tailed test of 0.00, meaning that the probability that our sample statistic was drawn from a distribution with a population mean of 10.59 is less than 0.0001. That means that in this case, we can say with greater than 99.9% confidence that the null hypothesis is probably false. So with these results, with a significance level of 0.000, we would reject the null hypothesis and conclude that Pennsylvania's SAT performance is statistically different from the national average. In this case, we actually find that Pennsylvania underperforms on the SATs compared to the national average, which may not be all that surprising for those of you who know how education, at least public education, is funded and works in Pennsylvania. So once again, a one sample difference of means test. We plug in a test value for our population parameter. We compare that to our sample, and we look at our t-scores and our significance levels to determine whether or not to reject or fail to reject the null hypothesis.